Assalamualaikum friends, welcome back into my new tutorial video. In this video I am going to show you how we programmed our TNF digital assembler in our FactoryTalk view. So you can see here our scene. We are going to open our assignment scene. Here is our digital assembler, and basically these are some inputs and outputs of the assemblers, and there is a button for start light, stop light, reset light, our counters, our auto manual, lids, conveyor clamp, lid clamped, lid basis conveyor. These are both basically there are two conveyors. There are part leaving base at place. There are two sensors there, and moving axis and input. Moving axis is output. So I am showing you the digital inputs and outputs of our assembler. So you can see here that these are the outputs of our assembler and these are the inputs of our assembler. So moving X item detected, lid at place, lid, basically these are the inputs and outputs. So you will see the inputs and outputs also there, which is our, you can see our moving X, and here are our moving Z and moving X and moving Z. So I'm just going to show you. You can see it is grab item detective, move X, Z, move X, clamp, lid, and whatever you want to see, wherever you want to see. There are basically everything was there, and basically these are our input output. If you have an factory, you can check these things in over there. First of all, we need to make our tags. So I already create some tags, and there are basically these tags which we see in our factory. Basically that are the tags I am using in our program. So now we are start creating programs. So first of all we need our block. So what block we need, which is called our function block. So I'm just going to name it as the belt conveyor. It is only function on our conveyor belt, so it is also I gave it a name belt conveyor. I'm just start. So first of all we need which is auto. So auto is our, because our SM is working on auto. So you can see here is an auto manual. So here is an auto and manual. So you will see our digital counter, emergency, and many more things you want to. So I'm just going to our auto. Now I just use a start. So start. So start. Basically we need a basics operation there. So I'm going to just use a reset, second, third, fourth, and fifth. Basically we need 4 more. So again we use a reset, we use it as a start. Again we need another one is in start, another one is in start. So I'm giving it a tag name. So first of all we need to stop light. So I just don't need a stop there, so I just delete it. Stop light, start light, base conveyor, and we need another one which is our lid conveyor. So these things we needed our. Now I'm going to program for our out, because you know that our out stop button is NC. So we need only the set again and again one. So what we need in our third, which is also called a reset, and the stop light, which is also called a set. So what we need to start, basically we don't need that. So basically start, stop light, and start light. We are going to restart our test. Now I am going to again one more. So need an auto, another buttons. Basically we need position rise lid, position at limit lid, our stop button. And now just need our, I think, one more, which is start, and it is also because we'll use as a lid there, so we use lid conveyors there. So another, I'm going to again use it in auto. 3 more, same, we use same these things. So what we need, you can see position rise base, position add limit base, another stop, and again I use and set as a, which is also called our base conveyor. So now I just use for lid. So what we need our negative edge. So need lid add place, and I am just use as a M0.0 there. So I need to reset, which is also called our lid conveyor. Reset our lid conveyor and just use as another negative edge. So I use base at place, then 0.1, and now I reset our base conveyor. So our base conveyor is now resetted. Now I need some details for our part leaving. So maybe we need another negative edge there. So we use another negative edge there. So here is our negative edge, and I am using as a part leaving, and use a memory, but is M0.2. So and so on. I just use both reset. Which things we need to reset? We need to reset position rise base, position rise lid. We need both to reset. Now I need a rising edge, which is also I need for part leaving, and I use a memory which last we use M0.3 as a memory bit. Now what I need an increment. So where is our increments of math? Here is our increment. So I need increment as a counter. So we need a counter increment in our counter, which is UDINT, and so on. So now our first block is complete. Now I program for our clamping. So we need another block and function call, which is given our name as a clamp. So I make another one. So I use as a clamp. So another auto. So I use this negative edge. Sorry. I use negative edge just there. And what I need is a lid add place. And what memory bit we use as M0.3. So we use M0.4 there. M0.4. So lid add place, and I will make sure to set clamp lid. So that's all. Now I am again using another auto. Another I need a positive edge, which I given as a name as a lid clamp, and I use which memory bit wise users and 0.4, so I'm 0.5 to use there. So I need to reset that. Again we use another one for our set bit. So I am using a clamp lid reset, and I use which memory bit is this, and 0.6 use there, and give it a name, a tag, rename a tag, which is our I call lid aligned. I use it there. Now I need another one, which is an auto here. So I need another negative edge there. I'm going to set that and use either base as plate, base as place, which I use on 0.6. Now I'm using n 0.7. Now what will clamp base? We need to clamp a base. Now I'm just use again as an auto there, and again need a rising edge, the base clamped. Now which we use as a override, which is m 0.7. I am using m 1.0 there. So I need to reset something, which is we need to reset, and again going to set, we need to reset our clamp base. And base, now I use another, which is we call line 1.1, and name it is a base aligned. Now our base aligned is ready. Now our second block is complete, which is we call our base. Now I just going to program our final block. So what do we need? We need another one, and which name we called it pick and place. So here is our new block. We also need an auto. Need a positive edge, lid. I use lid aligned here. So which we need you can see our final is on 1.1. Now I'm using M1.2 there. So I need to set move Z, and going to reset, again set our, which I am giving it a name, and 1.3, and I am going to name it move Z bit. I'm going to name it a move Z bit. Now again I am using another one, which is an auto. I also use as a move Z there, and I use another one, which is item detected, and make sure our move X is closed. So move X is closed, or we are going to set a grab. Now I need another, which is why we need to show you auto. Again set as a grab, because grab we need a grab there. So now I need some timer there, which is we use as a TP there. So the DB1, which is TP. and as a 1 second there I use 1 second. Now I need to go to the another one. I use an auto, which and then I need a positive edge there. So positive. So what I need a timer. So where is our timers? Go to there and set as a Q there. Now I need another memory bit, so I use what I use on 1.3. So I use there and 1 point. Now I need to reset it. Reset, reset and reset. Again use a reset. Again use a reset. Use reset as a move there. Lead the line and move that bit. Now our complex programming is there. We use another one which is we call the grab, and again I using a negative edge there, which is we call the move z, and I'm going to which our last bit is M1.4, so I'm giving it to M1.5 there. So another negative edge I'm going to using, which is our moving z, moving z, and I'm going to use it on 1.6 there. And another which is I will call our baseline, and I'm just use a set as a move x there. So I need a branch from there and use as a positive edge there, and use as a lead line, and use another memory bit there. So which memory bit I am going to use? And 1.7 there. And another which is we call moving z. Moving z is closed. Now I just drag and drop there. Now I just going to sorry. I don't need these things there. We need to what the hell is this? Now I need another which is auto, because we only design our program for only auto, so we use only or programming for auto, so don't feel painingly. So I just make it quick fast for I don't waste your time. I'm 1.7 and I'm going to use here and 2.0 there. I don't want to waste your time much, so I am just describe you as an easy way. So set another set. So I just set a move z and use a move z bit 2. So I just define a tag which is I name it and 2.1 definitely there. So now our programming is in end mode. Now we need some more things. So again auto, we need a move x, we need a move z, need a negative edge there, 2.1, so moving z, what is our last memory bit? I'm 2.1, so I'm using 2.2 there. So I need to reset the set and again reset. I need a grab there. I'm 2.3 and name it is a temporary name is a temporary there, because you understand why we need this bit, so in the end, so I use the base demand to reset. So I need an auto again. So another, I need a temporary bit there, and again I'm using a 10 non 10. So I again using this is a 1 second, which is we call our DB1. Now again I'm using on auto, and we need a positive edge there. So I am just dragging to our DB timer 1, thank you, after 1 second. And I am going to use what memory we need to use, which is M2.4. Now again I am going to set reset and reset. Now I am going to temporary 2 and as a define as a tag M2.5 move Z and need to move Z with 2. You just understand these things later, so you don't need to worry. Auto use temporary 2. Now I need temporary 2. We need another timer there. Another T1, which is we call the DB2. Again 1 second. I am just using an auto. And I need, and again, which thing I need it? We need a positive edge. A positive edge, we need our DB2 here, and also 2 as an output. So what memory bit we last used, which is on 2.5. Now I am using M.6 there, and we need to reset something, which is, and we need to know and reset another thing, and set, and again we need one more, which is set. So what we need to reset our MoveX, our temporary and position rise lid and position rise base. And I need to reset our temporary 2 also. So now our program is complete. I need to save this program, and just you need how we use in our main block. So we need a bank, belt conveyor, clamp, pick and place there. And last hour we need to use our emergency stop in our blocks. So emergency stop, and again use an emergency stop there. Just compile these things. We use to test things, call environment, change environment, transfer register to main, okay, F2 plans, goes to testing, call environment, change environment, call environment, transfer register to main, okay. Another going to testing, call environment, change environment, transfer register to main, and okay. Now I think our program has been complete. Now I need to start a simulation. Now I need to go to drivers and connect to our PLC sim. Now our factory is connected. I just going to see that our emergency button is stop or not. So you can see our emergency button is on start mode. I need to go back there and need to that also. Now I'm just going to show you. Now just you draw that program that like, and then you will connect to your assembler, so you will see how these programs will work. Now I'm just going to start to show you these things in auto, and I'm just clicking on the start button. So you will see that how it is now working. What is the problem? I think our emergency button. Oh, I think something is mistaken. There is something missing there. I choose to know which is there. I think there was a problem. I think we need to delete some lines. Then go of lines. It is already stopped. Compiling it. Also, I'm again uploading it. Now I see. I think now it's working. I think there was an alien program that took in place. That is the Now we check it is working or not. Going to PLC soon. Again going to download. First of all, it is a stop. Now I'm just going to load, start and finish it. Now I think it's started. Now I think that's gonna work. Now you see it's now working correctly. I just correct some things there. I just move it there, and our programming is now working. You will see the increment there, incrementing in our. So I will show you now. Three. The counting is equal to 3. 3 items we grabbed. So you will see it is working. I'll just show you from directly from there. Our counting working. Our position rising. You will see start is just a basic. So you will understand these things later in the future. When you program it and when you connect it, you will understand how these things work. First of all, I will just describe you something. First, when we start a button, like the conveyor is moving and parts are come to there, and now if the position rise limit is reset and it is clamped, then then our robot moves Z and grab items, and then after grabbing items it's going to move X, and the move X going to, and again it's going to move Z, and the item was placed on another item, then moving Z is reset and moving X return is. So that's how these things work. You will see the part leaving, the vacant place. So these are the sensors we use in our logic. So thank you very much for watching my videos. Please subscribe my channel, like my videos, make comments, and don't forget I make lectures on SCADA, Indosoft, and any other things you want to learn. So must watch these videos. So thank you very much again for watch my video. So don't ever to forget to subscribe. Thank you very much.